Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to A-Level Maths live lesson. Today's topic is proof by deduction, continuing the lessons we've done on proof. And just as a guide, we'll be coming to the end of chapter 1. And as a guide, the kind of speed that you should be working through the book is one chapter of questions every 2 weeks. Some of the shorter chapters you should be aiming to do one chapter per week, but you should not be spending more than 2 weeks to complete all the questions in one chapter. So roughly speaking, half a chapter worth of questions per week. And because we've already done about 1 week into this chapter proof, then just a little heads up that if you're coming close, if you've been working on the questions and you're coming close to finishing the questions in this chapter, then that's about the right kind of level you should be at. A warning, if you've not even started, then you're going to be getting behind very, very quickly. And if you want to get a top grade, a grade A, or at least a grade B in maths, A level, then don't think that you can just watch the lessons and not practice. You've got to watch every single lesson. Some of the lessons you might even have to end up watching twice, but the practice has to be done as well. You've got to be practicing and becoming really good at maths by doing it, and then God willing you'll be in a position at the end of the year where a lot of the questions you'll just answer them naturally, and you'll be able to get to some really high level by building on what you've done earlier on in the year. Okay, let's start with today's lesson. It's proof by deduction, and the idea here is that you're taking known facts, and you're taking them one by one and you're building them up in order to get to a conclusion that you're trying to show. So, in other words, because A leads to B, then B leads to C, then you can show that D is true. So you're trying to show that D is true, and you're building it up by taking a statement or a maths fact, which then leads to another maths fact, which then leads to another maths fact, which finally leads to the maths fact that you're trying to show. So let's go to the wording of the question, and you'll get a better idea of what I'm showing you. That's not what I want. This is what I want. So let's just copy the key part. Okay, great. So here if you ignore everything except the very last line, it's the last line that we're trying to show. That's your D. That's where we want to get to. We want to show that the product of two rational numbers is always a rational number. When I used to teach GCSE classes, the way I would say a rational number is, I would say something that has a definite pattern. So, for example, if you're dealing with decimals and you get a 1.25, you know that's rational because that's a definite pattern. It doesn't just go randomly, it's 1.25. Or if you had 25, 25, 25, 25, that's a definite pattern, so that's a rational number. If you had something like this, a 25, and then some random numbers, then maybe 25 and then some other random numbers, that's irrational. There's no definite pattern there. So just to remind you of what a rational number looks like, can be a whole number, can be a very simple decimal number, or it can be a decimal number that just has a very definite pattern. So something like a third, 0.33333, there's a definite pattern there. That's a rational number. 0.099999, again, definite pattern there. It's a rational number. But in maths you can't really rely on just what the number looks like. You have to have you have to have a very clear description or a way of recognizing a rational number. So the trick is that any rational number, let's take the 1.25 that I wrote earlier, any rational number can always be written as a fraction of two whole numbers. So in this case 1.25, I could write it as 5/4. I've got two whole numbers and I've got a fraction, and that's it. As long as you can write the number you're looking at as a fraction with two whole numbers at the top and the bottom, then that's enough to call it a rational number. Or that's enough to know that, yeah, it's definitely a rational number. So the first sentence here, that's all it's trying to explain, that a rational number, it's something that you can write as a fraction. Quotient is just another name, another word for a fraction of two whole numbers. Integers just means whole numbers, where the denominator is non-zero. And that's just really to make sure that you're not doing anything funny. You can't divide by 0, otherwise you get very funny results. So we're making sure that the numbers aren't 0. Okay, now that first box, that's nothing new. That's something you should know or you're expected to know. So you don't have to prove that. But what you want to try and do is get from what you know about rational numbers to try and show this, that if you were to take the product, that's timesing them together, of two rational numbers, then the answer you get is always going to be a rational number as well. So let's try and prove that step by step, and that's called proof by deduction. Okay, let's start with what we know. Let's say we've got the first rational number, let's call it P. Let's call it, just to stick with the same letters in the worked example if you're going to read it later on. Let's say our first rational number is a number called A. How do we know it's rational? Well, because we can write it as a fraction. What's that fraction? Well, it's just any two numbers. It doesn't really matter what they are, so let's just call them P and Q. What we know about P and Q, they're whole numbers and they're not 0, so that's fine. So first rational number is A. We know it's rational because we're saying that, not that we know it's rational, but it's the other way around. Because we can write A, let me just say that again. It says the product of two rational numbers. So if we're saying the first number is A, and we're told that it's rational, then that means we can write it as a fraction with two whole numbers. So if we say P and Q are those two numbers, then P has to be a whole number and Q has to be a whole number. If the first part of this sentence didn't say rational, then we wouldn't be able to say that about P and Q. But because it's told us it's rational, that A is rational, and then we think back, oh, what does rational mean? Well, it means that I can write it as a fraction. Then I know that, yeah, P's got to be a whole number, Q has to be a whole number. And then we've got a second rational number that we're going to multiply together with A. So let's call that B. And because again we're told that it's a rational number, then that means we can write it as a fraction. Let's choose R and S. I want to stick with the same letters that in the example, so R and S is fine, that will work. What do we know about R and S? Well, we know that they're whole numbers. So at the moment we know P, Q, R, S, they have to be whole numbers. Only because the question told us that A and B are rational. A is rational, B is rational, that means they can be written as fractions, and the fractions have got whole numbers. Fantastic. So nothing really too hard there. All we've done is rewrite what the questions told us, that we've got two rational numbers. Okay, and then the question says, okay, well now work out what would you get if you have A times by B. That's what product means. And we want to hopefully we want to show that the answer we get is a rational number, but we can't get there until we do the first bit first, which is to multiply A times B. So let's do A times B. A times B, well that would be P over Q times R over S. Let me just make a bit of space, and I can say A is the same thing as P over Q. And I'm going to times that with R over S, which is B. And then using not very complicated technique, but just something from GCSE about how to multiply fractions, I can say that would work out to be top times the top and the bottom times the bottom. So on the top I would have PR from P times R, and on the bottom I would have QS. Now that's the answer to A times B. So my first rational number times my second rational number, the product of those two I can rewrite, or I can write as PR divided by QS. But hold on, what can we spot about PR and QS to prove that what we've ended up with is also a rational number? Let's make a bit of space. And the first thing you can hopefully agree with me is that we end up with a fraction, the PR over QS, i.e. the answer we get is a fraction, because there's the fraction line. We can say that PR is a whole number, an integer. How can we be sure of that? Well, remember, P was an integer, a whole number, and R was also a whole number. So when you multiply two whole numbers, you're going to get a whole number. So we can say PR is an integer because, and this is a lot of words here, so I'm just going to make a bit of space and probably make the font a bit smaller. But what you want to write is that, what's the reason for being absolutely sure that PR is a whole number? PR is a whole number, an integer, because P is a whole number, Q is a whole number, and when you multiply two whole numbers, then the answer you get, which is PR, is also a whole number. Okay? That's, no one can, that should be clear. No one's going to argue about that not being correct. 2 times 3 is a whole number, 6. Pick any two numbers, 9 times 8, and you'll always get a whole number as an answer. Similarly, QS is a whole number for the same reason as above. We also know we've got a fraction, and we also know that it can't be 0 because we said Q and S can't be 0. The denominator is non-zero, and q was the denominator of the first one, s was the denominator of the second one. So because they can't be 0, then we know that qs can't be 0. So that meets all the conditions of a rational number. And thus, all the conditions of a rational number are met, which means, therefore, AB is rational. A times B is rational. Okay, a little bit long to go through that, but hopefully you got some of it. So let's see how much of that you did actually get. Okay, the task here is to go from the first opening statement that you're told or you're reminded that a rational number is a number that can be written as a fraction with two whole numbers, and the bottom of the fraction can't be 0. So you're told that, you're reminded of that, and now you have to take that statement and somehow build it up so that without any jumps in between, you can show step by step that when you take two rational numbers, the product is always going to be rational. So we're trying to go from the top box to show the bottom statement. So how did we start? Can you remember the first step? Something to do with A or B. Okay, just feel free to write in the chat window what you think the answer is, or what do you think the first step was. Okay, hopefully you remember it's taking the first rational number out of the two and just calling it A. And then because we know it's rational, because we're told it's rational, we're saying that, hold on, if A is rational, then that means I can rewrite it as a fraction, as a number divided by another number, and both those numbers, just to be clear, since it's rational, must be whole numbers and the q can't be 0. Okay, that was the first step. Then what did we do? Can you remember? Okay, just feel free to write in the chat window what you think. Okay, hopefully that's enough time. And just to jog your memory, well, we've only written one rational number, but there's two of them. So the next step was just to say, well, let's take another rational number, let's call it B, and let's say that B is also a rational number, so it's also a fraction, and each of the R and the S has to be a whole number. Next step, you've got to tell me now, you've seen it already just a few minutes ago, what do we now do to try and prove the product of two rational numbers is always a rational number? Give you a few seconds to think. Fantastic, Aisha again, well done. A times B is what the question's talking about when it says the product of two rational numbers. So let's do A times B, and let's use our knowledge of fractions, multiplying fractions, to simplify that and see what it comes out as. So we get that when we do A times B, that's P over Q times R over S, we get PR over QS. And that's what we get when we do two rational numbers and take the product of them. So now when we look at that, what now do we try to think of, or what do we try to go to next to show that what we've ended up with has to be a rational number? if you take a second to try and remember, just to summarize, we've done A times B. We've got an expression for AB in terms of the fractions we've been working with. Now I need to show that that's definitely a rational number. So what was the first thing, or what can you notice about that? We have to notice quite a few things so that we can tick off the definition in this box here. If we can tick off all of those little points, then we've proved that we've got a rational number. So we notice we've got a fraction. We notice that PR has to be an integer, but you can't just if you want full marks in a exam question on this, then you have to explain, or generally any kind of maths proof, you have to explain fully why is it an integer. It's a whole number, an integer, because it's made up of P times R. P is a whole number, Q is a whole number. When you times two whole numbers, you're going to get a whole number. So just to make that clear, that works with QS as well. So now we've got a fraction, we've got a whole number at the top, a whole number at the bottom. It's those three things are clear. So now we can say it's quite clear that we've got a rational number, and also that QS is not 0. Since we've got all the conditions, that means AB is rational. And that's proof by deduction. That's a step-by-step proof, and that's something you've got to try and get your head around. If it's the first time you've seen it, you're probably a little bit wondering what's going on. But if you want to read through the same example before the next lesson, I think once or twice after you read it, you'll realize, okay, it's not that hard. It's just going step by step and trying to get the sentence proven in a very, very clear way. Okay.